Hello everybody and welcome to the 9th video in our CSGO multi-hack series. Today we are going to be making an aimbot. Now there's a few things that I want to say before we start this. Number one, if you haven't watched any previous tutorials, this is a very long one and you probably aren't going to understand if you haven't had any previous context. So please go back and watch those if you haven't already. Anyway, next up is I'm not going to be going too much in depth about the math on the aimbot. There's a really great video by Guided Hacking about calc angle and just the math in general. So I'll leave that in the description below. It's a great video. So anyway, if you've done those things, let's get into it. Alright, so I've just started up Atom here, and I have a blank Python file, and I've also dumped the offsets. If you don't know how to do that, we have the offset dumper in our Discord, so just join that and you can download it. And then you just run the exe. But anyway. So I also just want to thank Joke and Ace for helping with the code in this video. But anyway, let's get into it. So we're going to be importing PyMem. We're going to import PyMem.process, and we're going to import keyboard. Also, one thing you should know is this is an FOV aimbot. If you don't know what that is, basically it's just whoever's in a range near you in your view angles. But anyway, we'll get into that later. So we're going to import from math the square root. We're going to import pi and atan, and then we're going to do some offsets. So the offsets we're going to need are DW local player, DW entity list, DW client state. There's a whole bunch of them. So I'm just going to go through here real quick and do them. So like I said, these were just dumped. So we're going to be looking for DW local player. We're going to grab that and paste that. We're going to be looking for DW entity list, just kind of the stuff that we usually use. And then there's also some of them that we don't use. So DW client state and DW client state underscore view angles. So as you can see here, there's a lot of client state ones. So we're just going to be using some of those, and then we're also going to be using m underscore vec origin. We're going to be using m underscore I team num. Let's see what else. We need m underscore I health, which is a very easy one. It's just 0x100. We're going to be using m underscore b dormant. And we are going to be using, actually there's two more, m underscore vec view offset. And last but not least, we are going to be using m underscore gw bone matrix. Alright, so once we have our offsets, like usual, we are going to be making our client variable and our process handle. So we're going to do pm equals pymem.pymem, and then that's csgo.exe. So we're just getting our process. I'm just going to move this down a little bit. We're going to be doing client equals pymem.process.module from underscore name, and then pm.process underscore handle, and client.dll .lpbase of DLL. Alright, and like in the Shams video, if you guys watched that one, we're going to be using our engine, engine DLL, so do that, engine and engine.dll, and we're also going to define like the FOV that we want, so aim FOV equals, I don't know, we can do like 120, that way it'll go like, I don't know, around halfway the circle or whatever. I'll try to put up a diagram of what I mean by FOV aimbot, but anyway. Now we're going to get on to the actual math of this. So there are four or five functions that we need to do, just so we can calculate the angles and all that stuff. Like I said, Guided Hacking has a great video on this. I'm not going to go too in depth into it. Of course I'm going to cover all the code, but just watch that video first, please. Anyway, so we're going to do def normalize angles, and we're going to do a view angle x, and then view angle y. Alright, and then inside of this we're going to do if view angle x is greater than 89, sorry. Then we're going to do view angle x is equal to or subtracted by 360. And basically we can just copy this bit and paste it a few times, 4 times, because we are doing a lot of these. Like I said, this is a long video, this is a long video, so just get prepared. So we're going to be changing this one to negative 89, and change this to be plus 360. And then we're going to be changing these next ones up to be y, so view angle y, view angle y, view angle y. And then we need to change this to be, actually we need to change this to be less than, same with this one, so less than, so if view angle y is greater than 89, we're going to change that 89 to be 180, and we're also going to change this one down here to be 180, and then we're going to make this, well, we can keep it at negative 360, and then we can change this to be plus 360. And then we're just going to do return view angle x and view angle y. So basically, when we call this function, is just going to give us back 2 values, which is the x and the y view angles. So now we're going to do a new function called check angles. So check angles, and then we want to input the x and the y, and then we are going to do if x is greater than 89, then we are going to return false. Else if x is less than negative 89, then we are going to return false as well. And we're going to do elif y is greater than 360. Then we are going to do return false, and then one last one, elif y, whoops, I gotta go back here, elif y, and then this is less than negative 360, and we are going to return false. And then we're going to do else, return true. So this is just checking the angles, so it'll just return true or false, basically. I'm just going to collapse these two because the code is going to get quite large, as you'll see. But anyway, we are about halfway down through the math stuff. Anyway, we're going to do def nan checker. It's going to be first and second. And we're going to do if math dot is nan first or math dot is nan second. And we're going to do return false, else, whoops, why did I do that? Return false, and then else return true. Alright, so actually one thing I'm going to do is I'm going to close out of my csgo.py file there. But anyway, now we're going to do calc distance. So def calc underscore distance current underscore x current underscore y new underscore x and new underscore y. Alright, and then we are going to do distance x equals new underscore x minus current underscore x, and then we're going to do if distance x is less than negative 89, and then we're going to do distance x is, we're going to add equal to 360. Sorry, no, not add equal to, just plus. We're just going to add 360 to it. Anyway. We're just going to copy this a few times. And then, there we go. Alright, we're going to do elif here, so else if distance x is greater than 89. And then we're going to do a distance minus 360, distance x. And then we're going to do if distance x is less than 0.0, then we are going to do distance x equals negative distance x. Alright, I'm just going to collapse these two. And then we're going to do def calc angle. And there's a few inputs we need to put in here, so we're going to do local position 1, local position 2, and then just do this a few times. So local pos 2, or sorry, local pos 3, local, actually no, that's it. We're going to do enemy pos 1, enemy pos 2, and enemy pos 3. So basically this is defining our local player's x, y, and z coordinate, and it's defining the enemy's x, y, and z coordinate. So we're going to do try delta underscore x equals local position 1 minus enemy position 1. And I'm just going to copy this because we need to do this for each axis. So that's the x, y, and z coordinate, or axis. And we're just going to change this to be local position 2, and then local position 3, and then same for the enemies. Alright, and then we're going to do HYP, and that's going to be equal to the square root of delta x times delta x plus delta y times delta y plus delta z times delta z. So like I said, there's a lot of math stuff, but we'll get through it. So x equals a tan delta underscore z, and then we're going to divide that by HYP, and then we're going to multiply that by 180 and divide that by pi. And then we're going to copy this over because we're basically doing the same thing for the y. So y, and then delta y, and replace this with delta x, and multiply that by 180 and pi, there you go. And we're going to do if delta x is greater than or equal to 0.0, then y plus 180.0. And we are just going to return our x and our y coordinate, and we're going to accept pass. Sorry. There we go. So we have our 5 actually math functions done. Now we can get to our main function. So we're going to do def main like usual, and then we're going to do player, and we're going to set player to be pm.read underscore integer, and then client plus dw local player. We're going to be doing engine underscore pointer, and then we're going to set this equal to pm.read underscore integer, and then we're going to read our engine, engine plus dw client state, and then we're going to do a local team, and this is just going to be pm.read underscore integer player plus m underscore I team num. So this should be familiar to you guys because we've been doing this for the past almost 10 tutorials now. But anyway, now we're going to make a while true statement. So in our infinite loop here, we're going to make a target, and this is going to be equal to none. We're going to do our old distance x, and this is going to be equal to 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and then we can just do the same thing for our all distance y, and this is just so that we aren't locking onto the same enemy after they're dead, and we're actually changing that. So now we're going to do for I in range of 1 and 32. So just checking for all 32 players, and then we're going to do entity, and this is going to be equal to pm.read_integer, and then we're going to do client plus dw entity list, and then plus I, and then times 0x10. So this is just defining each singular entity. So if entity, then we're going to try entity underscore team ID. It's going to be equal to pm.read_integer, and then we'll be reading entity plus m underscore I team num, and then we're going to do entity underscore HP, and this is going to be equal to pm.read_integer, and then we're going to do entity plus m underscore I health, and then we're going to do entity dormant, entity underscore dormant equals pm.read_integer, and then entity plus m underscore be dormant. There we go. So there are a few cool things we can do with entity HP. So we can do like health based glow and stuff. I'm not going to go over this. I'm just saying, there's some cool possibilities you guys can do. Anyway, so actually we don't need this try here. Actually no, we'll just keep that. And then we're just going to do accept, and then we're going to print finds player info once. So basically we're just finding like our entity team ID, HP, dormant, and we're only doing this once. Anyway, so we're going to be doing if local team is not equal to entity team ID. So just to make sure we're not actually aiming at our teammates and then maybe possibly shooting them. And then we're going to check to make sure that the entity HP is greater than 0, so we're not aiming at the player that's dead. And then we're going to do entity underscore bones, and then it's going to be equal to pm.read_integer, and then entity plus m underscore dw bone matrix, which I'm pretty sure we got. Yeah. And then we're going to do a few more of these. So local position 1, or sorry, not local position 1, local position x underscore angles, local position underscore x underscore angles. And then we're going to do that's equal to pm.read_float. And then we're going to be reading the engine pointer, and then adding that to the DW client view, or sorry, DW client state view angles. And then we can actually just duplicate this because we're going to do the same thing for the y. Alright, plus y. Sorry, not plus y, just changing that to y. And then we are also going to do plus 0x for here. Alright, and now we're going to do local position 1 and 2 and 3. Anyway, so local position 1 is equal to pm.read_float, and then player plus underscore back origin. Alright, and just copy this, plus 4, change this to be 2. Alright, there we go. And now we're going to do local position underscore z angles. I'm actually, after we finish this line, I'm going to move it with something else. Read float. And we're going to do player plus m underscore back view offset plus 0x8. So, sorry, what I was trying to say earlier is that I'm going to move this with the x, y, and z, just so we can, keep it organized some more. Anyway. So once we have that, we're going to do a local position 3. We're going to set this equal to pm.read_float player plus m underscore vec origin plus 8. And then we're going to do plus local position z angles. And that's why we need to have the z angles before the local position. Put that local position 3. Alright, and now we're going to go on to actually using some more of the math functions that we made earlier. So we are now going to do try entity position underscore x, and then that's equal to pm.read underscore float entity underscore bones, and then we're going to add 0x30, 30, it's not 30 because it's hexadecimal, anyway, plus 8 plus 0xc, and we're going to duplicate this 3 times for each of the axes. And then, so now that we have the y and the z, we just got to change this to be 1c and 2c. So, just so you guys know what we're doing here, is we are defining the x, y, and z of our enemy's head. So, like the bones, so 8 would be the bone for the head. Let's say you wanted to aim for the body, you only wanted body shots, you would do 5, for example, and you would only get body shots. But we're going to do headshots, so we're just going to keep that at 8. And then we're going to do accept, continue, and then we're going to do x and y, that's capital, and then we're going to do calc angle, so using our math functions from before, and then we're just going to put in local position 1, local position 2, local position 3, and same thing, we got to do entity position x, and then entity position y and z. So I'm just going to copy this, paste and paste, there we go, and then change this to be y, change this to be z. Alright, and then we're going to do a new distance, and this is new distance underscore x, and new distance underscore y, and then we're going to set this equal to calc underscore distance, and we're just going to calculate our local position underscore x angles, and the same with our y angles, so just put that in there, and then put in our x and y that we just calculated up here. And now we're going to do if a new dist underscore x, and then we're going to do if that is less than old distance x, and new distance y is less than old distance y, and new distance x is less than or equal to aim f of v. So this is where f of v from before comes in. And our new distance y is less than or equal to aim f of v. And we're going to do old distance x, and then old distance y, and we're going to set this equal to be new distance x and new distance y. Alright, and now we're going to do our target underscore HP, target underscore dormant, and this is going to be equal to entity dormant, or sorry, entity HP, and then entity dormant. So we're just, defining just some variables about the target that we're aiming at. So we're checking to see, what their HP is, if they're dormant, that sort of thing. And now we are just going to move the indentation back, and we're going to do if keyboard.is underscore pressed, and then you can set this to be whatever key. I'm going to do Alt and player, and now we're actually going to be writing the memory that aims, so changes our view angles. So we're going to do if target and target underscore HP, is greater than 0, so make sure that we're not aiming at someone who's dead, and not target underscore dormant, so as long as they're not, standing still. Then we are going to do x and y are equal to calc angle, local position 1, and then all the way up to 3, so I'm just going to copy that. Change this to be local position 2 and local position 3. And then target underscore x, target underscore y, and target underscore z. So now we are actually getting the x, y, and z coordinates of the enemy. And now we're going to do normalize underscore x, normalize underscore y, and that's just going to be equal to normalize angles x and y. Alright, so last but not least, we are going to be writing the memory. So pm.write underscore float engine underscore pointer plus dw client state angles, client state view angles, and normalize x. Alright, and I'm just going to copy this, paste this, alright, and then we're just going to add on 0x4 like we've been doing for the y coordinate, and then change that to be normalized y. And now we can just go in and make a kill key. So if keyboard dot is underscore pressed end, then you just exit 0. And there we go. So now we're just going to do if underscore underscore name underscore underscore equals underscore underscore main underscore underscore and then main. So if you have made it through this entire video, congratulations. I hope you didn't just skip to the end, because just don't do that. Sorry, I had to put a little semicolon there, or colon. Don't skip to the end. It's not going to help you. Anyway, let's run this. So I'm already in a bot match here. So as you can see, I'm already in a bot match. I'm just going to open up my CMD. I'm going to do CD desktop, and then I named my file Python, or not Python, Aimbot tut.py. You can call it whatever you want. Oh shoot. Alright, well, we got an error. Alright, sorry about that, guys. I totally missed out on a line here. So go back up to line 118, where we're doing new dist underscore x, and then less than old distance x, and anyway. I forgot to define some stuff. So target y, target z, x, and target z. And then we're going to set this equal to entity underscore position, entity position x, and then entity position y, and entity position z. In our calc angle function, we're going to do distance y, and this is going to be equal to new underscore y, and then minus current underscore y. And then we're going to do if a distance underscore, or distance y, is less than negative 180, then we are going to do distance y plus 360 degrees, sorry, not degrees, just 360, and then we're going to copy this over and do that one more time, and then we're going to do elif distance y, and that's going to be greater than 180, and then distance y minus 360. And then we're going to do if a distance y is less than 0.0, then we're going to do distance y plus equals, equals negative distance y. So, sorry about that. The issue was that I did the x, I didn't do the y. But anyway, return distance x and distance y. Alright, so once we have this done, we can just run this. So python aimbot tut.py. Alright, if we're in game, we press Alt, you can see that we lock onto a player. Hit him, it goes to the next person, next person, next person, and then the last person. So there you go, we have a fully functioning aimbot using Python and PyMem. Hope you guys enjoyed this video. I know this was a super long one, but I hope it was beneficial. Anyway, goodbye.